Today we are going to cover section 2 of chapter 3, which is logarithmic functions. Does anyone recall from last year what a logarithmic function is? Yes. Good. It is the inverse of an exponential function. Can you remind me what an inverse is? What is an inverse? Bless you. Or what are inverses? The opposite? Do you guys agree? I kind of disagree with the word opposite. I know what you mean, but I wouldn't use the word opposite. Yes? Okay, so that's how we find them, right? So you flip x and y and we can find them. But what are really inverses? Okay, like their graphs are reflected over y equals x. So these are all properties you guys are telling me. But any chance you remember what they are, actually? It's all good. They're functions. Oh, yes, you got something? No? All right. They are functions that cancel each other out. They undo each other. You with me? So I know what you meant by opposite, but I don't really want to use the word opposite. You want to use the word like they undo each other, they cancel each other out, right? So in other words, in order to cancel an exponential, I need a logarithm. And in order to cancel a logarithm, I need an exponential, which will eventually get there, right? So today we're going to focus on logarithms, okay? All right. So first things, let's talk about an exponential. Cool? So like last class, I believe I gave you y is equal to 2 to the power of x. Do you remember that? Cool? What I want to write is its inverse, okay? And Madeline, you said that to start finding an inverse, I have to switch x and y, right? So that'll be my first step, right? So if I switch x and y, then I get x is equal to 2 to the power of y, right? And then when you look at this, you're supposed to solve for y, right? And this is where the problem came when logarithms were invented. They're like, well, how am I going to solve for y when it's obviously like on the exponent? You with me? So then the creation of a logarithm came about. Are you guys with me? It was something that they created. I honestly don't know why the word log. I'm going to be completely honest with you. Okay? So here's how it works. You ready? Number one, the exponential has a base, which in this case is a base of 2. To turn it into a logarithm, you're going to write the word log, and you have to have a base with it. The base has to be exactly the same, which in this case is going to be a subscript 2. You guys with me? Now, inside of this logarithm, there's going to be a parenthesis. There's going to be something inside it, and then there's going to be an equal to something. Are you guys with me? Here's how you solve this. Ready? Whatever is on the other side of the base would be what's in the parentheses, and whatever's in the power, it's what is equal to. You with me? So kind of, I have this little process that I show, like to write as a log, you go from base of this, so it's log base 2 of x equals y. So that's the way that you can rewrite it. Fair enough? So what I am saying now is that y equals 2 to the power of x and y equals logarithm base 2 of x are inverses of each other. Fair enough? All right. Any questions so far? Okay, so let's do some examples really quick, switching back and forth so that you can fully understand the idea of a log, okay? So, first things first, let's just do exponentials. You guys know exponentials. So if I tell you 2 to the power of 4, that would easily be 16, right? Because you understand that this is asking you to take 2 times 2 times 2 times 2, right? Okay, let's take this expression and write it as a log. So in other words, find the inverse of this. You tell me. For sure log, right? Of what base? 2. Of what? 16 equals 4. So, if you were to explain to someone what a log or what this is saying or what this is asking, can you put it into words? Like when I see the word, like when I see log base 2 of 16, what does that mean? And why is it equal to 4? I know it's like it seems like a simple question, but sometimes it's hard to kind of explain what's going on. So anyone want to give it a shot? So if I turn this into an exponential, then I get the same equation. Yeah, cool. But do you understand like what it's asking? Like, because that's one of the biggest misconceptions. If I were out to the street and I asked someone, like a random person, which by the way they would hate me, like, what's a log? I don't think anyone's gonna be able to answer that question. If I'm being completely honest with you. Cool. Unless I go into like a university and like I specifically go to a math building or something, they'll probably answer it. But the rest of the world, not really gonna happen. Okay. So I'm gonna help you put this into words so that maybe if you still don't understand logs, you can fully understand them this year. Okay. What this is basically asking you is 2 to what power equals 16? That's what the log is asking. It's asking you to find the power that would result in 16. And that's why the answer is 4, because 2 to the power of 4 would be 16, which I'm with you what you were saying. If I turn into an exponential, that would make it a true statement, right? So what does a logarithm look for? The power. Versus an exponential, you know the power, you apply the power. Fair enough? Okay. Yesterday, I realized that a lot of my students are not that good with exponents, so we're going to practice that for this class. Okay? So let's start out with something simple. What is 3 to the power of negative 1? 1 over 3. How would you explain that to somebody? Yes. It's the reciprocal. So if you ever have a negative power, you're supposed to put a 1, and then whatever you're being asked to, you're going to put in the denominator, but now you're going to turn the power into a positive. So in this case, that's why 3 to the negative 1 is 1/3. Are you guys with me? Okay. Let's say I give you 5 to the power of negative 3 then. What would that mean? 1 divided by 125. Are we good? Yes? Okay. This is going to be a little bit out of this specific lesson today, but just in case, I want to make sure we know this. So, like, let's say I gave you something like, I don't know, 25 to the power of 1/2. Do you guys know how to take care of 25? Good. So, in case you forgot, I don't know when you get taught this. I gotta be honest with you. I don't know if it's algebra 1 or algebra 2. When you have a fractional exponent, it's actually a type of root. In this case, what type of root am I asking for? So it's a square root of 25 to the first power. So if you for some reason forgot the rule, here's how it works. If you have a number to a fraction, so like x over y for something, you're going to turn that into, the denominator is the type of root that you have. So in this case, would be a white root of a to the power of x. Fair enough? Do you remember talking about this? Cool. So in this lesson, I'm not really going to throw in there like powers that are fractions, but just a reminder because we will utilize that later on in the year. Okay? So are we good? Okay. There are some bases that are very important for logs. I don't know if you remember the bases that you talked about last year. There were two bases that were kind of talked about or considered to be kind of important. Yes. There's a base of 10, so there are two bases. We're going to talk something known as the common base, and that is base of 10. Why do you think we use the common base more than the other bases? Why 10? What's so special about 10? Any thoughts? No? Have you ever wondered why when you get to 10, you go back to like 11, and then when you get to 20, you go to 21, and then when 30, 31? Because we count by basically tens, right? It's just how the world, like, that's why it's called a common base, because we use, like, our number system, the one we utilize, is base of 10. Like, we count by tens, basically. Are you guys with me? Okay, that's called a common base, and there is another base. I don't know if you remember what it's called. Any? 2? No. There's something called a natural base. Very good. Which is represented by the letter E, which is actually a number. Does anyone know approximately what it's equal to? No? Okay, that's fine. It's approximately 2.71. Okay? Fair enough? All right. Those two bases occur a lot. It is called a natural base because it occurs in nature like a lot. A lot. Which we don't have time to talk about that in this class, but if you're interested, it's a pretty interesting topic. Cool? All right. What does this have to do with logs? First of all, anytime you see the word log, something like this, without a base, you are to assume that it is a base of 10. Cool? And anytime you see ln, you are to assume that that is a logarithm with a base of e. Cool? So this one is log of x, and this one is read natural log of x. Are we good? Yes, no, maybe? Okay. So let's practice figuring out logs. Here we go. Can anybody tell me what the log base 3 of 81 is equal to? Log base 3 of 81. 3? Do you guys agree? 4? Is it 3? Is it 4? What is it? 4? Why is it 4? It's 3 to the power of 481? Yeah, so we're looking for the power, right? Are we good? Beautiful. All right. Log base 2 of 1 over 64. What is it? 1/6? You're close. -6. Cool. Why? Anyone? 2 to the power of -6 is the same thing as 1 over 2 to the power of 6. And 2 to the power of 6 is 64. Fair enough? Are we good? What if I give you something like this? I don't know. Log base 2 of 3. So basically, like right now you don't know what it is, right? So we can call it x. So what you're suggesting is that I can rewrite this as 2 to the power of x is equal to 3, right? 2 to what power gives you 3? Square root 3? 2 to the power of square root 3? Well, let's think this through. What is 2 to the first power? 2. What is 2 to the second power? 4. So I can for sure at least tell you that it's between 1 and 2. But that's all I can tell you. And I will not expect you to know that. Are you guys with me? So if I give you something like a log and you do not know the power, like in other words, if the power is not an integer, then I don't expect you to know what that answer is. You would leave this as your answer. Your answer would literally be, hey, the log base 2 of 3 is log base 2 of 3. Done. Are you with me? Okay. Before we go to lunch, there are some properties that I want to talk to you about logs. Then we'll take a break, and then we'll talk about graphing. Okay? All right. Properties of logarithms. There is 5 of properties that we'll discuss today, and then there's 3 more that we'll discuss next class. Okay? The first property, and let's see if it makes sense. Logarithm of any base, I don't care what the base is, of 1 is equal to what? 0? Why? Is a to the power of 0 1? Yeah, so that's your proof if you're not 100% sure why that's true. Okay? Second property, logarithm of base a of a. Why? A to the power of 1 would be itself. Fair enough? Okay. Third property, logarithm base A of a to the power of x, and what I want you to notice is that the power is inside the logarithm. What do you think that's equal to? I'm sorry? X times what, I'm sorry? Well, if you're stuck, could you turn this into an exponential? Yes? Right now you don't know, right? So I'm going to put a question mark. Like, I don't know what it's equal to, right? So turn it into an exponential. What would this look like? A to the question mark, which is what I'm looking for, right, is equal to what? A to the power of x. So what is the question mark? So that means that this property states that if you take the logarithm with a base, and inside there's an exponential with the same base, you would get x. Tell me why, or does that remind you of anything we've done in this class in the past where you get an answer of x? They're inverses. Remember that when you have two inverses and you do composition, you get the answer of x? You do realize, what did I put on the inside? An exponential function with a base of a, and then on the outside, what's out there? A log with a base of a. So what do inverses do to each other? Cancel each other, so it leaves me with x. Fair enough? Which, along the same lines, I know this is not a property of logarithms, but along the same lines, let's pretend that I have a to the power of logarithm base a of x. So a to the power of logarithm base a of x. What would the answer be? X. Why? Logarithms and exponential functions are inverses of each other, and they have the same base, right? If this is a base a and this is a base a, then they're going to cancel, leaving you with x. Fair enough? So, to me, I got to be honest, these properties you could memorize, and they're pretty easy to memorize. However, a lot of these are pretty common sense where I think you can figure it out when you're working with them. Cool? The last one that we'll talk about is this one. Let's say that you have logarithm of x equals logarithm of y. By the way, what base is there? 10, right? It could be any base that I wanted. I'm just going to write it like that. Tell me logically then, what is x equal to? What is it? Can you tell me why that would be true? How can two logs be the same? If whatever's on the bases are the same, let's start out with that, and then the insides has to be the same, right? Like, just like any statement, like, how could 2 equal 2? Well, there has to be a 2 on each side, right? So we're talking about logs. First, they have to have the same base, and secondly, whatever's on the inside has to be exactly the same. Fair enough? Okay. So, using these properties, we're going to just do a couple of practice problems, and then you guys can go to lunch, okay? So, I'm going to ask you to simplify this, an expression. So let's say you have logarithm base 3 of 3 to the power of 10 minus logarithm base 5 of 1 plus logarithm base 17 of, I don't know, 17. Trying to use them all, trying to remember them all, minus 81 to the power of logarithm of 81 of 3. I know this seems crazy. I don't know why would anyone give you that, but I just want to see if you recognize the properties. Cool? Instead of giving you 4 or 5 different problems, we can all do it at once. Cool? All right. Very first thing, what's the logarithm base 3 of 3 to the power of 10? 10. Right? Because they're inverses of each other. So that's just a 10. Second one, what is the logarithm base 5 of 1? 0. Very good. Plus, what's logarithm base 17 of 17? 1. And then what is 81 to the power of log 81 of 3? 3. So we're looking at 8 as an answer? Yes? You get the idea here? Like I kept them pretty simple, but on the homework they're gonna be a little bit more challenging. But the idea is, can you recognize the property so you can either simplify or solve for something? Okay? All right. Any questions about anything we've talked about so far? All right. So that's where I'm gonna end today. Well, for now, and then we'll talk about graphing when we return.